It's not going to be enough to just have something that you can string together that processes the data of right now. It's going to have to be able to process the historical data and the real-time data together. I'm going to need something that's not a specialized system, but kind of a generalization of batch processing, where I can build my program and have it run offline against a test data set, evaluate that, and then have it run continuously as it goes to production to create a continuously fresh data set that I'm going to use. So what do I need to do to accomplish this? Well, this is something we've been working on at Confluent. I think there's two critical ingredients. First, at the data layer, I have to unify batch and streaming. And we've been doing this with what we call table flow. And this is a way of taking the real-time streams of data that are coming in Kafka and be able to continuously populate and represent that as open data tables in cloud object storage using standards like Iceberg or Delta, so that you have a historical data set as of a point in time, as well as the real-time flow of changes. And these two are not just two distinct systems, but are actually linked. You understand the point in time across these systems. You can process seamlessly between the two things. When you've done this, you now have the ability to build systems that process history and then go on and start processing the real-time stream that are effective in bash, but also effective in real time. And on top of that, you have to actually do this in the processing layer. And this is something that Flink brings, this ability to build a program with a particular set of logic in SQL or a programming language, run that offline as a batch process, be able to iterate on that, try out different things to get it right, and then have it run in a streaming fashion and be able to go back and do that over and over and over again, because that's ultimately going to be our development cycle. That's going to be the iteration loop by which we make our system better. So if we put these two things together, we can have effective streaming pipelines that actually make this easy to use in development in the way that our batch system was, able to produce real-time data, which is going to be essential for agents. So we've really made a substantial step forward on the first part of this data supply chain. But what about the last step? So I said it's not that easy to strap the real-time serving onto the data lake. Is it any easier if you're strapping it onto a stream processing system? The answer is not really, right? We're going to have a continuous flow of updates coming out of our streaming, but every time we go back and reprocess things to improve our context data, we're going to have a big batch load. It's going to be relatively hard to keep these two things in sync. It's going to be hard to avoid disrupting these real-time queries that are looking up the right bits of context at the right time. And we're going to have a set of problems, right? There's going to be operational problems about the load that we're creating. There's going to be data model problems of just matching thing A to thing B, carrying the security model through. We're ultimately balancing across two distinct systems that we have to somehow keep in sync. And very often, these live serving systems are just not built to take the volume of batch updates that come from real reprocessing of data. And they're often impacted by the real-time load of streaming updates. So how could we make this easier? Ideally, we shouldn't have to think about this last step at all. It should be just like an implementation detail that as we've created this new data set, it's somehow ready to serve. How could we accomplish that? Well, we've effectively accomplished something like this with Tableflow, where you have a flow of real-time data from Kafka. You may have processing on that in Flink, and then it lands in a table that's structured where you could query it, do things with it. What's the problem with these Tableflow tables that are in Iceberg and Delta? Well, there's only one problem, which is they're slow. They're pretty slow. They're high throughput, they're scalable, but they're a little bit slow. And so how can we speed this up? If we can somehow speed this up, we could actually support fast queries off this materialized data set. And we could do that in a way that was well integrated. And in fact, this is very possible, right? Rather than strapping on a completely separate database, we could maintain a fast cache of this data. And instead of just waiting until it flows out into the Parquet files, we could keep an optimized index that's kept in sync. And we could have a fast path for queries that avoids the full processing runtime of Flink and actually does fast analytics or lookups against this data set. And if we did this, we could have access for things that were indexed this way with milliseconds instead of multiple seconds. And that would allow us to have two representations of this data without all the overhead of having to load back and forth and manage these processes between two distinct systems. And this concept of building materialized views in stream processing is not a new one, but this makes it, I think, a lot easier to do. And so we're excited today to be announcing early access to our real-time context engine. And what this does is it takes the streams of data in Kafka, allows you to process and reprocess them, and then provides access to the resulting data in a fast, low latency model, which is exposed via MCP, and which can be plugged into any agent or AI system built in any framework you like. Like anything that works with MCP will plug into this data and have access to it. And you can iterate on that data, evolve it, make it better, and keep it in sync over on the streaming side and serve it up in real time. That's right, that's right. And so, if you're interested in this, this is in early access. There's a QR code. You can read more about it. I think ultimately this is a very powerful pattern. This ability to do streaming data capture, stream processing, create a new data set, be able to iterate on that in batch, and then take it out to production and have that data set evolve in real time, be able to serve real-time queries against it. It's useful for these workloads around AI and AI agents, but if you have the query capabilities, it's actually useful for a lot of use cases. Building and maintaining these kind of materialized views is useful for analytics. It's useful for populating derived caches. It's useful for observability. We're just getting started. What we have right now is pretty simple queries with good performance. We would love to expand that to richer sets of queries with fantastic performance across a wide range of use cases. And this is something that we're actively working on.